In this lesson, we're going to learn about a concept called stoichiometry. Stoichiometry is essentially just the process of learning how much chemical you can make in a chemical reaction and how much product you need to make that amount of chemical. So we use stoichiometry all the time as chemists. It's one of the basic things that we do. We want to make a certain amount. Let's take, for example, making a medication. If we make too much medicine, it could put our patients at risks because it could harm them from some sort of an overdose. If we give them too little medication, it's not going to have any benefit for them. We want to give them enough medication that they're helped, but not having detrimental effects from having too much. Let's take a look at this particular case. In this case, this is a product called Caltrate. It's a calcium supplement. It can also be used as an antacid. And if we take a look at the fact sheet, we can see that there are 600 milligrams of calcium in here. Okay, so 600 milligrams is simply 0.600 grams, and most likely it's really is 0.6000. And then let's look at the ingredients sheet and see if we see what the source of that calcium is. And if we look at it, the source of calcium, the only thing that I see in there that really says calcium in it is calcium carbonate. In fact, that is the source of calcium. So calcium carbonate has a formula that looks like this. So let's see what we can do with that. In fact, I think we're going to make it. Let's make calcium carbonate. Let's make this drug. Okay. Now, calcium carbonate has a formula of CO3, but the label only tells us about calcium. So the first thing we need to know is, okay, we need 600 milligrams of calcium, but we need to get it from calcium carbonate. So let's write down some information. We know we have 6.00 grams of calcium. Okay, and let's get that into moles. Maybe that might be a helpful thing to do. So as it turns out, 40.08 grams of Ca and 1 mole of Ca. Okay, and in every one of these calcium carbonate particles I see, I have 1 calcium in every calcium carbonate. So let's just show that conversion. So for every 1 mole of calcium, I'm going to be finding 1 mole of calcium carbonate. Okay, so let's cross that out. Okay, and our moles of calcium have canceled out. Now I want to know how many grams of calcium carbonate. So we're going to go through the process of converting moles of calcium carbonate to grams of calcium carbonate. So here we go. 1 mole of calcium carbonate. I look on the periodic table, and I add up calcium and carbon and 3 oxygens, and I get 100.1 grams of calcium carbonate. By the way, that's something I wouldn't know it's on the top of your list, but memorizing the calcium carbonate has a molar mass of 100 is helpful. A lot of times you'll see that in percent composition questions on the multiple choice section of an IB chemistry test. So if we go through that process, what we get then is we get 1.50 grams of calcium carbonate. So what does that mean? Just to remind ourselves, to get 0.6 grams of calcium, 600 milligrams of calcium, I actually need 1.50 grams of calcium carbonate because the calcium carbonate has other things besides calcium. It has carbon, it has oxygen, just the calcium itself, that's only 0.6 grams of it. Okay, so we can actually make calcium carbonate. We can perform this reaction as an example. We can mix calcium bromide and sodium carbonate. Doing that would give us calcium carbonate and sodium bromide, and that calcium carbonate would be solid. So probably if I were doing this experiment, I'd want to use filtration to get the calcium carbonate by itself. So how many moles of calcium carbonate do we need to produce? That might be something that we're going to do. So if we're starting with calcium carbonate, and that's what we're trying to make, grams are great, but we need to know about particles because we're going to use calcium bromide and sodium carbonate to make it, and 1 mole of calcium carbonate is going to weigh a different amount than 1 mole of calcium bromide as an example. So let's find out how many moles of calcium carbonate we need to produce. So we need 1.50 grams of calcium carbonate. And just as a reminder, we just talked about this a second ago, there's 100.10 grams of calcium carbonate in 1 mole of it. Okay, great. So what's the number of moles that we need to make? We need to make 0.149 moles of calcium carbonate. So we can see something already. If we need to make 0.149 moles of calcium carbonate, looking at this chemical reaction, I'm also going to need, excuse me, I can't talk. 1 mole of sodium carbonate is needed to make 1 mole of calcium carbonate. 1 mole of calcium bromide is also needed to make 1 mole of calcium carbonate. That's something called a mole ratio. In this case, it's 1 to 1. We'll take a look at other examples later. So to make that number of moles, how many moles of calcium bromide do I need? It's a 1 to 1 mole ratio, so the way I show that is 0.149 moles of calcium carbonate. And this is just being formal about it, because obviously mathematically what I'm about to do is 1. For every 1 mole of calcium carbonate, I need 1 mole of calcium bromide. Okay, so the number of moles of calcium bromide that I need are 0.149. Okay, great, so that's the number of moles. Well, of course, I can't go over to a balance and just record moles. I'd have to go and find the number of grams. So I need 0.0149 moles of calcium bromide. And then I'm going to run that calculation. Oops, this should say moles. For every 1 mole of calcium bromide, that has a mass of 199.9 grams. And of course, I'm just getting this information from the periodic table, 1 calcium plus 2 bromines. And when I do that, what I'll find out is I need 2.98 grams of calcium bromide. Now I'm going to perform those same steps for sodium carbonate this time, and when I do it, I'm going to go from the beginning to the end. So just as a reminder, I need to make 1.50 grams of calcium carbonate. That's how much I want to need. Start with the information that you know. I have to convert that to moles of calcium carbonate. So 100.1 grams of calcium carbonate is needed to form 1 mole of it. Now, in this chemical reaction, the mole ratio again is 1 to 1. I need 1 mole of sodium carbonate to make 1 mole of calcium carbonate. So 1 mole of sodium carbonate will give me 1 mole of, 1 mole of calcium carbonate will give me 1 mole of sodium carbonate. That's the number of moles, but of course then we have to go back to grams again. 1 mole of sodium carbonate has a mass, and that mass is 105.99 grams. Okay, so then you're going to run that calculation, and then mass of sodium carbonate that I'm going to need is 1.59 grams of sodium carbonate. I would recommend that you just run this through your calculator to make sure you can get the same information that I'm getting. So that's the amount of sodium carbonate that I need. So now we know the mass of calcium bromide that I need. It's 2.98 grams. We calculated that in the slide before. And I know the mass of, so that's the calcium bromide. And I know the mass of sodium carbonate that I need is 1.59 grams. of sodium carbonate. If I add those together, what I should get in the chemical reaction is 1.50 grams of calcium carbonate. That's what we just calculated. Now, if you notice, in the reaction, it talks about states. And in this particular case, they're aqueous. So when I perform this chemical reaction, if you were going to perform it, you would have to do it by dissolving 1.50 grams of, by dissolving 1.59 grams of sodium carbonate in water, and then also dissolving 2.98 grams of calcium bromide in water. Calcium bromide should have a 2 there. And in that process, then you would actually make the correct amount by mixing the two containers together and filtering out the calcium carbonate. You're going to do the same exact process, except you're going to use different chemicals. You're going to use potassium carbonate and calcium chloride. So what I'd like you to do is go perform the calculations for how much of each of these things you need, and then carry out the reaction. Okay, go to it.